Hello and welcome back to the new video of the Java tutorial series. So till now we have started with the deletion operation. We have seen how to delete at end and how to delete at beginning. And now one more operation is there, how to delete at user specified location, that we are going to see in this video. Okay, so let me write a comment: delete at position. Okay, so let's go in our paint and try to see how we can build the logic, how to delete the node inside the doubly linked list, which is at the user specified location. So there are two, three things that we have to remember. That is the corner case, first of all. So what are the corner case that we may face? Okay, so first case is, what if the position is 1? Okay, so it's a user is tell that delete the element which is present at the position 1. So that is pretty similar to the function that we have made, which is delete at beginning. So we are trying to do that same performs we are trying to perform that same task, but this time user has given the position as 1. That means user is wanted to delete the element which is at the first. So we'll perform that same operation. And what if the user has tell to delete the last node? So this is not the actually the corner case. This will come under the default operation, because we don't know what is the end node, what is the last node, what is the length of the list. So in that case it will come inside the default case itself. Okay, so for the deletion operation, let's suppose I want to delete this node inside the list. So I have to somehow break these and these bond, but before breaking this bond I have to link this node with this node, first node with the third node, so that this after third node all the nodes will not get discarded, because I have to keep that track as well. I just have to delete this node itself. Okay, so before deleting these links, we have to make a link between first and third node, and we have to assign thirds previous to the first node as well. Okay, so these are the operations that we have to perform before breaking those links between this next and previous of this node. Okay, so let's go and code try to code it. Okay, let's go in our IDE. Okay, so we will name it as public static. uh, we are deleting a node, right? So we have to pass open, not pass, we have to return the new head of the list, and we'll write the function name as delete at, and we will pass the new head of the list to this function. Okay, new not new head, we'll pass the head of the linked list that on which we are trying to perform this operation. Okay, so likewise at the insertion at, we need one position, which is position from the user, and we will need one count variable which is initially set to as 1. We will need one temporary variable, name it as temp, and which is pointing towards the head. Okay, and we'll just simply print enter the position of node you want to delete. Okay, we'll ask the user to enter the position, and we will simply keep that value inside the position variable. Okay, se.nextInt. After that, we'll check the corner cases. If the position is equals to 1, that means the user wants the first element to get deleted. In that case, we will just simply write the logic that we have written at the delete at beginning. Okay, so if the head.next is equals to null, head.next is equals to null, then in that case we will just simply write head is equals to tail is equals to null. Both should point to the null, and if not, we will go inside the else part. We will write head.next dot previous should point to the null, and we'll reassign the head's value to the head is equal to head dot next, and we'll write temp dot next is equals to null. This is the corner case. If that is not the case, we'll come inside this else part and we'll do node D. We will create one more variable which is also pointing to the head initially, and to keep that track of this back variable, we again run the while loop. Until my count is less than position -1, I will run this while loop. Okay, and inside this while loop, I will write back is equal to back.next, back.next, and we will say simply count plus plus. Okay, so what we are trying to do is, let's suppose there are some other nodes present inside this list. Okay, so assume that there are five elements in this doubly linked list. Okay, and we are trying to delete the element, trying to delete the node which is at third index. Okay, so third position, let's say. Okay, so if you want to delete this, you have to somehow keep the track of the previous node of the list and the next node of the list. Okay, so that means we have to keep the track of the which is inside the list, and the fourth node which is inside the list. Okay, to delete the third one, and to keep the track of the second node, to get there, the to get there we have run this while loop. Back is also representing, which means we are trying to get the previous element. Let's, like, suppose we are trying to delete the third element, we will go there to the second element by using this back, and we'll try to hold that. Okay, and after that we'll create one more node D, where let's name it as current, which also is equals to back dot next. Current will hold the node which we want to delete. Actually, the node that we want to delete is hold by current. Now we will check one if condition, where if my current dot next is equals to null, that means it is the last element of the node that we want to delete. Okay, when the current dot next is equals to null, when it is the last node of the list that we want to delete. Okay, so in that case it is pretty simple to that we have done in the delete at end. Okay, so in that case we will just write simply dot current dot previous is equal to null, previous dot current is equal to null, and we will write back dot next is also is equal to null. Okay, and if that is not the case, there are some nodes which is present after that current also, then we will come inside the else part. We will write back dot next is equal to current dot next. We will current dot next. So what this means is, we are trying to break the next link, and we are trying to make the linkage with the fourth node. Okay, so we are no more have the track of the from second to third node. We have built the connection from the second to fourth node by writing this line. Okay, and after that we will write simply current dot next, current dot next is equals to current dot next dot previous is equals to back. Okay, so this is the case that we want to perform, and after that we'll just simply come out of this else part, and we'll just simply return the head of the list, and we are done with the operations. Okay, so this is the deletion operation at the specified location. Let me just comment it out, and since we are getting the new head of the list from the function, we will just simply write node D, new head D, and we will write delete at, and we'll pass the head, and we'll just after that, after performing this operation, we have to check whether the node get deleted. We have one print list method that we have implemented also, and we'll also find the length of the list, whether it is decreased by 1 or not. If it is got declared, that means our node is successfully deleted. Okay, so we will run this. Okay, so 1 2 3 4 and 5, and give it -1. So element in the list are 1 2 3 4 5, and the length of the list is 5, and it is asking for the position that I want to delete. So let me give a position as 3. So delete the element which is present at the position number 3. So here you can see the position number 3 is present. It has deleted. Don't get confused, this is not the data part, I'm giving the position, I'm giving the actual position at the third position, whichever node is there, delete it, and after deletion operation 1 2 4 5 is getting returned by the list, and list size is also decreased by 1. So let's go and check the corner case also. What if we want to delete the first element of the list, that is 1 2 3 4 and 5, and after that -1, and we will give 1. Here you can see 2 3 4 5 is also printed, 1 is getting deleted, and the length of the list is also decreased. So this is how you can perform the deletion operation at the doubly linked list at the end of the list, or at the user specified location, or at the start of the list. Okay, whatever position you want, you just give the position. If that position exists inside the list, this function will delete it. Okay, so thank you for watching this video, and I'll see you in the next one.